Okay. Good morning. So today we're going to talk about networking in the cloud. So the way that we will do this is by installing a software that's called OVS, Open vSwitch. So this adds functionality in the networking aspect of the OpenNebula cloud. Basically, to let us create any type of networks we want. It will give us more flexibility in the networking options of OpenNebula so that we can connect both our virtual machines between them and our entire cloud to the outside world. Now, this particular lab sheet, because of the process of the installation, I have actually created all of the commands, and the structure of it is basically you can just copy and paste the commands in the terminal, make sure that the syntax is correct, all of the characters have transported correct and everything, and you can just go through the commands and everything will just work. It's as bulletproof as it can be because the installation of the software itself is a bit weird. It's probably something that you maybe have not done before while you're using Linux. Essentially, we're compiling and creating an RPM from source for the particular operating system that you're using, and then we're installing that RPM into your operating system. So the software that we'll need to use is available on this link here. So you just need to click on this, make sure that it is version 2.15. I mean, as soon as you click on this, it will just start downloading on its own. So you don't really need to go and choose anything in order to do this. Once it downloads, it will be saved in your downloads folder. You need to go to it and you need to extract it. So you need to create a folder in your downloads that is called Open vSwitch 2.15.0, and that will be it. Now, once this folder is created, I would like you to go into that folder and right-click anywhere on the blank space, anywhere on the white space in there, and choose Open Terminal here. Because all of the rest of the commands that we need to type, especially the compilation commands like boot, configure, make, dist, will need to be executed inside the OVS folder itself. Now, the rest 4 lines are essentially installation of packages that we will need in order to get everything to work. You can just copy and paste them. These are all prerequisites for OVS to be working onto your system. And then once they're executed correctly, please make sure at the end of each command that it says completed. It doesn't actually throw any errors your way. So make sure that the process is just copy and paste, but check what the system actually tells you once you type the commands. You can then go on to the next step, which is the boot, configure, and make dist commands. Now, most of these commands will have a lot of output back when you type them. You don't need screenshots of everything, obviously. You can just get a screenshot of the command when it's finished, and that should be enough as documentation in the logbook. The other important bit with this lab sheet is because it's so much copy-paste, at least in the installation steps, I need you to definitely try to explain what each of the commands does. Okay, so the configure script, for example, will configure the distributable from the source files that are located in the folder, so you can then basically compile it, which is the make dist command, onto the system and create the executable for the system itself. So I would like you to make sure that you include good documentation, good comments about all of the screenshots that you have in this particular lab sheet. Once you do that, you need to make a directory. So you need to create 4 folders in your home folder, in the RPM build folder in there, and that's where all of the data from the process of building the RPM will basically be saved. So this make dir command will create a folder called RPM build, and inside it will create those 5 subfolders that you will need for the build process. Once you do that, you can copy the targz file and you can place it into the sources file, and that's what the second command basically does. Once that's done, you can run the RPM build command. Now, the RPM build command will essentially create the RPM. It will build the RPM for the software itself, and it takes a long time to run. All right, there's lots of things to do. Even in on our quite fast computers, it will take maybe 2-3 minutes of running. It will endlessly be scrolling text on your terminal while you do that. It's fine, let it do what it does. This particular command, towards 3/4 of the way, it might also come up with some errors. So you might see some red letters saying testing fail, for example. Don't worry about that. You can ignore it. It's specific features that will not actually affect the operation of OVS when you actually use it in your cloud. So don't get alarmed. Just make sure that when it finishes, it says all done or complete or whatever it says, and take a screenshot of that, and you're good to go. Now, once this is done, you will have created an RPM, which will be called OpenVSwitch 2.15.01 x86-64 RPM, and then you use the command yum local install to install this RPM onto your computer. Again, we're playing it completely safe with the installation method. We're not just typing RPM -I to install the RPM. We're using yum local install, and you will see that it will also still fetch some more dependencies from the internet when it does this. So make sure that when you do all this, when you type all of these commands, your internet actually works correctly. Okay. Once this is finished, you can basically enable and start OpenVSwitch as a service, so you can get the thing to run. And the first milestone for this is the OVS vsctl show command. So this command should show you that OVS is installed, it's in version 2.15, and that's it. So if you get that reply back from the system, it means that basically your installation process was correct, and you're good to start configuring the software. Now, all of the commands for OVS are OVS vsctl something, so you can do man OVS vsctl. So this is a typo here, there should be a V here, so I need to correct this in the lab sheet as well. And you can see all of the OVS vsctl commands that basically you can use in order to use OVS. So as we do that, we need to configure it. We need to configure the network cards in our system. So at the moment, you should have a BR0 network card that is a bridge onto ENS33, and you have access to the outside world through that one. So what we'll do is we'll pretty much replace the BR0 interface with a NET28 interface. In order to do this, we first need to create the device on OVS. So OVS needs to know that there is a NET28 and it exists, and we can actually create a configuration file for it as a network card in our etc.sysconfig network scripts folder. And then once we create the configuration file, we can start the network, and the network card will basically run. So those 4 commands here, they will add, the first command will add a bridge that will be called vmnet28. So the way that OVS works, it creates bridges, and those bridges have ports at the ends of them. In our case, for this particular interface, we'll have vmnet28 as the bridge, and we'll have one end of the bridge being called ENS33, which is your physical network card inside your virtual machine that takes you to the outside world. And on the other end, we'll have a NET28 network card that will connect us inside the virtual machine. Those 4 commands will basically create the bridge, and it will show us the end result. I have remoted into my computer in the lab, so I can actually show you this. So the ifconfig itself will look pretty much like it did with BR0 before. So you will get ENS33 that will not have an IP address but will start up as a network card. And you should also get NET28 that will have the IP address on 28 that your computer is supposed to have. On the OVS vsctl command, you should have this. So the commands that you just typed create exactly this. So you have a bridge vmnet28 that has ports NET28 and ENS33 on it. Okay. So once you do this command, OVS will know the names of the network cards involved, and then, and only then, can you go into your system and create the configuration files that you need for the network card to run. So you'll need to find your BR0 file, that's going to be in etc.sysconfig network scripts, rename it to NET28, and make sure that the contents in there look like this. So basically you can delete all the contents of BR0 and copy and paste all these in here, please make sure to remember to change your IP address for your system in this file. Once you do that, you then go and check that ENS33 actually looks like this, so verify that it is like this on your system. And once you can do that, you will then need to reboot your computer. You can try service network restart, see if that works, for all of the changes to take effect. Now, it's a little bit of a chicken and egg situation with the network card configuration files and the OVS configurations. So you might get the possibility that after you type this third command, an error might come up. And when you do type OVS VCTL show in the end, that same error might appear again. However, at this stage you can ignore this. You can move on to create the configuration files, restart your Prometheus, and then if you type OVS VCTL show again, you'll see that magically the error is gone. Okay, this is because the system cannot find a NET28 network card. I am having them run in this order in the lab sheet, because if we did it the other way around and created the configuration files first, you would probably, or students in the past, have basically done service network restart before running the OVS commands, and it didn't work. Okay, so that causes more problems than running the OVS commands first and then basically getting an error and ignoring it. So if you do get an error, it's fine, you can ignore it, create the configuration files, restart the computer, and then it should all be okay. If it's not okay, then it's probably a typo in the commands, and we can fix it for you in the lab. So once you have NET28 in the system, you can then create more network cards. So in our case, we'll create NETs 30, 31, and 32. So the end result will basically look like this. So your OVS VCTL command should have, get it, VMNet 30, VMNet 31, VMNet 32, and VMNet 28. So on your OVS, all of these should show up like this, and your IF config should also include Net 30, Net 31, Net 32 in your system as well. So this is the end result that we're aiming for. We need to be able to have an IF config that includes network cards on networks 28, 30, 31, and 32. Once you get to that point, you have basically configured correctly the networking with OVS on your system. So in order to do this, we need to have these commands. So we need to create a bridge, and we need to put one port onto that bridge, call it net 30, and you need to repeat this process for 31 and 32 as well. You can do all three network cards in one go. So when you do the add bridge command, you can do add bridge VMNet 30, then straight away up arrow 31, up arrow 32. And you can do the same for the other commands here as well. Once you do that, you will then need to go into your etc. sysconfig network scripts folder and make sure that you create the files for nets 30, 31, and 32 as well. So in your network scripts in the end, you should have the files that we can see here, 28, 30, 31, 32. All you will need to change inside those files will be the names and devices, and this part of the address on the IP address. The last part of the IP address will be your first usable IP address according to the subnets file. So it's the same principle as what we did in the VMware and VirtualBox lab sheets. Okay, so on networks 30, 31, 32, you have two IP addresses that you can use, and they belong to a range of addresses as allocated to you according to the subnets PDF file that's on Moodle. So for this one, it will be your first usable IP address, and it will be on networks 30, 31, and 32 respectively. The information that should never change is the prefix. The prefix should be 30 for all three network cards. Who can tell me why? Come on. What's the prefix? The prefix is a subnet mask. Why will the subnet mask be the same for all those three internal networks? and it's not 24 as it is for net 28. Okay, too early in the morning, that's fine. So those three smaller networks that we have are all of the same length. They have the same dimensions. Okay, so we took an entire class C network in the subnets PDF file and we split it into 64 slices. Those 64 slices have an equal length of 30 bits. So the subnet mask for them is 255, 255, 255, 252. Yeah, it's not 0 in the end anymore. So this is what the 30 instead of /24 actually means on these files. And because the networks that we're using, irrespectively of the subnet that we're using them at, is actually the same length, so this will also be 30 for all of them. The fact that it's 30 and we're talking about network 30 is just a coincidence. Okay, so this should stay 30 for all of the configuration files. So once you have the files and once you have configured OVS for it, you will have then configured the infrastructure on Prometheus itself, and then you know you need to go into the cloud and create those network cards inside the cloud itself. So you need to go in, delete BR0 on any other network card that you might have there, so we'll completely reset the networking inside the cloud itself, and in there you can then basically create the 4 new network cards, net 28, 30, 31, 32. So in the end, your networking in Sandstone should look like this. Okay, you should have 4 network cards. They should be called net 28, 30, 31, 32. And they should all have one available IP address each in order to give to one virtual machine that starts up that uses that network card. The IP address that they will have available to give will basically be your second IP address from the subnet's PDF file. So you allocate the first address from that file onto your net30 network card on the host. So when you type ifconfig on the host, that network card shows up like that. And that second IP address, you actually allocate it inside the interface in the cloud so that it can be configured into the virtual machine that you're building in the cloud so that they can talk to each other. Okay, so once you do that, you can basically have all of your network cards inside the cloud. They will connect to their corresponding network cards outside the cloud on Prometheus itself, and through there and through network 28, through network card 28, they can go on to the outside world. They can communicate with the outside world. However, in order to do that, because we are jumping from network 30 or 31 or 32 onto network 28, in order to traverse different networks, we need to have routing in place. Routing is the last part of this lab sheet, and you will need to configure routing with Quagga on the system. We'll use OSPF as the protocol, and you'll basically configure zebra.conf and ospft.conf to run the system and give you access to the virtual machines and the virtual networks inside your cloud. All right, so at the end of this, your ifconfig should be showing the 3 network cards, the 4 new network cards really, that you have created, and your routing should be running, and you should be able to ping google.com from any virtual machine inside your cloud on any network card. To test this, you can go back into the cloud, and we can go to the virtual machines that you're using that are running. So I will give you an example. So let's say I have one of my running virtual machines and it's on network 28. This will work by default because network 28 is bridged and it has a direct gateway to the outside world through network 28. So internet on your first virtual machine should always work anyway. If you want to try out and see if 30, 31 or 32 work, all you need to do is detach the network card here and then click attach NIC, click on this one, and then attach network 30 onto this virtual machine. So now the network card, physical hardware on the network card will change. So instead of net 28, you will now be connected onto net 30. And then all you need to do is go inside the virtual machine and change the IP addresses in there. So we need to go, log in. So you'll basically need to go into your network card settings. And change the IP addresses in here from the ones on net 28 onto the ones that correspond to your computer on network 30. So if you do that change, restart the network card, you should be physically connected onto net 30 interface and have configured your virtual machine for network 30 as well. You should then, through routing, be able to ping google.com. Once you can do that, you have reached the end of the lab sheet because you have configured your network cards, your routing works, and your virtual machines can connect to the outside world using any of the network cards available on your cloud at the moment. Okay, so by the end of this lab sheet, the last thing that I want to see as documentation in your logbooks is a ping from your virtual machine to the outside world while it's connected onto network 30 or 31 or 32. Okay. Now, let's go back. Once this lab sheet is finished, I will explain the last lab sheet as well, because some people have already gone into OVS and some people have finished with OVS as well. All right. So I will explain this today so that you can actually have all of the information that you need in order to work in the next lab sheet from this week if you need to. Remember, after we come back after Easter, we only really have 1 week that you can work in the class uninterrupted. The second week, the Monday students will not be able to come into the class because it's a bank holiday, and the third week is assessment week. So that's why I'm going to go through the lab sheets and make sure that basically you have all the information you need. You can progress and you can even work on them during the Easter break if you like, connect remotely, do whatever you like. Okay. So the last lab sheet is populating the cloud. First of all, remember, you don't absolutely necessarily have to do this lab sheet in order to do well in the module. So if you are struggling for progress, aim to finish the OVS lab sheet. Okay, if you finish the OVS lab sheet, you can still get 70-75% in the logbook. So you can still get an A on it, and you can still do well in the unit. All right, if you complete this lab sheet as well, then that will basically send you on to a much higher mark, like 85 or 90%. All right, so I would like you to be able to do all of this because it's interesting, because you can do lots of things with it. You're essentially building your own cloud, but we might run out of time completely. And especially with the bank holidays after Easter this year, it's a bit tricky. So the purpose of this lab sheet is to actually populate your cloud. So you have your OpenNebula installed, you have your networking infrastructure in place, and you have a virtual machine that you can actually use. We need to create more virtual machines, give them a purpose in life, give them users and groups that can actually use them and do useful things with them, and install services in the server in the cloud. So basically turn one of the cloud virtual machines into a server and provide services to the other clients on the cloud. Now, in order to build virtual machines in the cloud, there are lots of different methods. You can basically clone an image or a template that you already have in your cloud, and you can create more of them and just start them up. You can download appliances, as we call them, from OpenNebula's marketplace. So you can download pre-built, pre-configured virtual machines from there and use them in your system. You can basically, or you can build some new one from scratch if you like, completely. So I have had students in the past that did this even with Windows clients inside them. So the virtual machines inside the cloud were actually Windows. So I'm happy with that. I'm fine. You can do whatever you like. All right, and if we can help you in the lab, if you do come across a problem with this, we'll try and help you. And otherwise you'll be on your own basically. But you have full flexibility to do whatever you like. Build your cloud any way that you prefer. the baseline of this lab sheet, the most easy thing that you can do in order to learn the basic principles and get the marks for the lab sheet is to create 3 Linux virtual machines and base them on the original image, on the original template that you created for your cloud. So basically take your existing virtual machine and clone it 2 more times, change the network cards on it, and then basically use it. So the end result for the most basic requirement in the cloud itself will look like this. So in my storage, the images that I have are vPrometheus 1, 2, 3. So I've taken vPrometheus 0, as I was calling the original image, and I cloned it 3 times. All right. And then I've gone to my templates and created 3 virtual machines that are using those 3 images. Note that in my storage, I do not have the CentOS DVD image anymore. Okay, so if I go down, okay, I don't have the DVD anymore because my vPrometheus 0 image was built and the contents of the images do not get deleted because we made the images persistent. All right, so if you clone them, you will have virtual machines that have an operating system on them and are actually ready to run. So you don't need to reinstall the operating system. So it's a good idea to remove the DVD from the equation because if you keep adding the useless DVD in the images, every time you instantiate an image, so every time you run a template basically, that DVD will get copied from the image data store to the system data store. So you will lose hard drive space on your computer. And you'll be losing almost 5 gigabytes at a time. Okay, so it's bad practice to have an image that you don't actually need to use running in a virtual machine. So I've removed the CentOS DVD because I don't need it anymore, and my templates basically consist of, if I do update, so I have in storage, I only have 1 disk, and it's my vPrometheus 3 or whatever one I'm using at the moment for that image. Then I have a network card, I have 1 network card, and for this particular machine, I'm using Net31. And then the OS and CPU parameters, my boot device will essentially be my vPrometheus 3 disk, and that's it. So you can set all of your templates to look like this, but use a different network card and a different image, and then you can start them up, and they should just be running without any problems. So I have the 3 VMs that are connected here, and they basically work. So I have my server, I have 1 lecturer machine that will be, in our scenario, used for the lecturers in our group, and we have 1 machine for students that will be used by students. So the way that this scenario basically works is you're building a small cloud for a small department, let's say the School of Computing, University of Portsmouth, whatever you want it to be. You need to have a server that provides services at the bare minimum file services, file sharing services. Okay, you need to have a client for the academics, for the lecturers, that the lecturers can basically connect onto the client and work throughout the year, and they will always get the same machine to work on. And then you can have 1 virtual machine for the students. The students will start it up, do their work, and when they leave, they don't care about it. All right, so you can develop any services that you want. So I would say the simplest thing that you can do is NFS sharing. All right, but then later on, if you have time and you're progressing fast enough, you can do authentication with LDAP, you can do pretty much whatever you like in there, as long as the clients can connect onto the server and get some service out of it. So in detail, the file server will need to be on 1 of the network cards on the system. You can use VMnet30 for that if you like. Make sure that your routing is working, so that virtual machine can actually get access to the internet, because if you try to install any services, like if you try to install NFS utils, for example, you need to run yum install NFS utils. So you need to have internet access working correctly on that one. So you need to have 1 server. You can basically use the vPrometheus 0 image in order to do that. It has everything that you will need inside it. And then the 2 client machines that I would like to have will be 1 for lecturers and 1 for students. Now you will need to experiment around with this a little bit, because I would like the lecturers' computers to be persistent. So I would like the lecturers to be able to start one computer in the beginning of the year or the semester, and they should be able to reconnect onto it and keep working onto it for the rest of the sessions that they connect to. The easiest way to achieve this is when you instantiate the template for the lecturer machine to instantiate it as persistent. So when you do start it up, it gives you an option to give the template a name, to give the instance a name basically, and then it has a toggle switch that you can switch on and set the virtual machine to run as persistent. What that will do is it will make a copy, it will make a clone of your V Prometheus 1 or 2 image, and it will copy, and it will call it V Prometheus copy. So it will keep that image stored in the data store until that virtual machine is actually terminated. This means that when the lecturers go back and work on those machines, they always get the same computer to be working on, it's theirs, all the data that they have on there gets stored at all times, and only they can basically log into that. In contrast, you can have a student client virtual machine that will need to start up, and the students can connect to it and work and log in with their user accounts, and we don't care about any of the data being preserved in the virtual machine itself. If you do take this one step further, you could configure NFS, and you could configure a file storage data store in the cloud itself. So when those student images start up, when those templates actually start up, they could connect to that file image, and that file image could contain the home directories of the students that are actually working on it. So even though the virtual machine data itself might be lost when you terminate it, the students' home directories will be located in another image that will be relevant to the virtual machine, or to the virtual machine's instance really, and then they can be recalled anytime we actually need to use them. Okay. So you will need to have your user accounts and groups. You need to set them up correctly in your cloud, and then you need to have some sort of authentication service if you want to centralize authentication inside the cloud itself, so that everybody can basically log in to the virtual machines that they are supposed to be able to log in. So the students, for example, when they log into the cloud, they should only be able to see the VMS image available to use. They should only be able to log in to the student virtual machines in there. The lecturers should only be able to log into the lecturers, and nobody should be able to log into the server. Okay, so this is the most basic scenario for this particular lab sheet. All right, 3 computers in the cloud, 1 server, 1 client for lecturers, 1 client for students, and they should be able to start 1 instance and run. 1 instance is the most basic requirement, and it's the easiest one to achieve because of the network cards that we have available in our system. Don't forget, the whole idea of the cloud is that you can have multiple instances of a template, of a type of virtual machine, so that multiple lecturers or multiple students can actually log into it. If you do want to achieve this, you will have to create a new network card or 2 new network cards, put them on a private network, and then have the virtual machines connect to that network card on the private network. If you do that, you can give the private network card an entire range of an entire class C network, let's say 254 addresses, so that when the virtual machines actually start, the number of leases available for each of them will not be 1 of 1, will be 1 of 254. So essentially you can run 254 instances of a particular template because you have the IP addresses available to give to those virtual machines in order to run. All right, because the limitation with those public IP addresses that we're using here is the number of IP addresses that we have available per computer in order to use. So you could create a new network card, call it net192 or net0, whatever you like. It can be on network 192.168.0.0, and it can start giving IP addresses of 192.168.0.1, 2, 3, 4, 5, and so on, to any instances that are running from that let's say, student template that are using this particular network card. All right. Obviously, the last detail in this is because there will be private IP addresses, they will not have direct internet access. However, you cannot Prometheus, you can do nothing on Prometheus, and that will give them access to the outside world, and they will be able to browse the internet and so on. All right. You will also need to configure the server address for them to be a particular IP address of where your server instance is running, with the IP address that it has, and so on, so that you can basically make your little cloud network run correctly and be able to do what you want it to do. All right. I know this is getting very complicated, but if you tackle it one problem at a time, then it's easier to deal with. So you want to build your cloud, you need to make sure that your network cards are in place with OVS, and later on you can make a private network card or 2 private network cards as well. You need to have your images in place, so the easiest thing to do is clone the existing image, name them something meaningful, something that you can use, create new templates, or even clone the existing templates that you have, rename them and give them a purpose in life. And then, once you start up all of the virtual machines, you configure the services that you want to use in your server, and you connect your clients onto that server so that they can use it. And that's it. Okay. I'll be thrilled if you just get the 3 virtual machines running and being able to ping google.com and being able to log in with different student accounts that belong to your cloud and so on. That will be more than enough for me. Anything further than that, then that would be just brilliant. Okay. Any questions about all this? So what I will do is I will upload the video for this once I go back into my office. Okay, and you will be able to basically go back and look through this, because we won't have a lecture next week. So next Monday we will not be here because there's no need basically. All right, and we'll have a revision lecture when we come back on the 24th of April. That's the first Monday after the Easter break. So I will go through the exam questions. So I'll show you what the exam will look like and let you help you prepare for it a little bit as well, and tell you what to basically study, revise for it, and so on. And we can use that session as well if you like, so that you can show me your logbook, and I can give you some feedback on your logbook as well if you like, which, by the way, is something that you can do at any time. You can just email me your logbook, and I can tell you if it's good or not, or if there's something that you need to fix on it. Okay? All right, thank you very much.